Hello, welcome to Chapter P, Section 2 and 3. We're just doing real quick review today because the stuff in these two sections are really basic. So I'm hoping you remember it, and hopefully this is just in case. So first I want to talk about lines because it's been a bit since we've done y equals mx plus b. I'm really hoping you remember this, but just in case, again. So real quick review. In lines, we need to know slope. And the formula to find that, we usually use the letter m to stand for slope. So if we have 2 points, we would take y2 minus y1 divided by x2 minus x1. So real basic. If you want to think about it as rise over run, cool. But just remember how to find slope. And then the other thing that we want to remember, not just y equals mx plus b, because I know that's the slope-intercept form. We will be using that, except the more useful one for us will be the point-slope form. So I want to concentrate on that really quick. So point-slope form is used when you are given a point and a slope. And that's what a lot of our problems are going to be like, even in calculus, when we have to apply the old stuff to it. This will be the most useful form to write lines in. We'll still have to simplify it back into slope-intercept form, which is the y equals mx plus b, but at least this will give us an easy start for it. So we have y minus y1 equals m times x minus x1. So m stands for the slope, x1, y1 is the point that we're plugging in. And then the regular y and the regular x stays in there. It just stays as y and x. Okay, one last thing to review is parallel and perpendicular slopes. Hopefully, if you're given a line and they're saying the slope is parallel to this line, the equation of this line, then you should know that the slope should be the same. And if you're given something where it's perpendicular, hopefully you remember that the slopes are the opposite reciprocal or negative reciprocal. So for example, if the slope was 4, then the new slope would turn into negative 1 over 4. Reciprocal just means you're flipping it into that fraction form. Okay, so I want to do a few examples, just in case we've forgotten this all. So in my first example, we want to be able to write the equation of the line passing through 2 points, 2, 8 and 5, 0. So we want to use the point-slope form, which means I need to figure out what the slope is going to be, and then use one of the points to plug into point-slope form to then write my equation. So first, let's find the slope. So we have y2 minus y1, so that would be 0 minus 8, over x2 minus x1, so 5 minus 2. That'll give us negative 8 over 3 is our slope. Okay? Then plugging into point-slope form, let's just choose one of the points. I'm going to go with 5, 0, just because I like when there's zeros in there, because 0 is always an easy number to work with. So if we have y minus y1, so for us y1 will be the 0, and x1 will be the 5. So y minus 0 equals, and then the slope of negative 8/3 times x minus x1, which is 5. Okay, we just need to simplify this down so that we get it back into slope-intercept form, so y equals mx plus b. Y minus 0 is y. And then I'm going to distribute to get that. So that's the equation of the line that passes through those 2 points. Okay, My next example, I want to be able to write the equation of a line perpendicular to the line 3x plus 4y equals 7, and it has to pass through the point 4, negative 5. Okay, so we have the point. We just need the slope in order to plug into point slope form. So I'm going to use that equation that they gave us, 3x plus 4y equals 7. I need to figure out the slope of that line, because then I can figure out its perpendicular slope that I want for my equation. So I'm going to rewrite the equation into like y equals mx plus b form so I can figure out what the slope is. So I'll subtract 3x from both sides and then divide both sides by 4. So that means in this equation, the slope is negative 3/4. So in my equation, to make it perpendicular, our new slope is going to be 4/3, because can't be negative anymore, opposite, and then flip the fraction. So now I can plug it into my point using the point slope form. So y1 is going to be negative 5, and my slope of 4/3 times x minus x1, which is 4. Simplifying this down, I get lots of fractions here. Okay, let me subtract 5 from both sides. Let me make common denominators so I can subtract. So I end up with 31/3. That as my equation. Y equals 4/3x minus 31/3. Okay, so those are my two examples for P.2. P.3, we're evaluating functions. So when we're evaluating functions, basically if I'm given a function like f of x equals negative x squared plus 7, I want to do things where I'm like plugging in. So basically finding like f of 3, f of negative 2, even if I'm plugging in other variables like f of 3a, f of b minus 1, things like that. That's what I mean by evaluating functions. So hopefully you remember this just means that you're plugging in whatever's inside the parentheses in for x of the original function. So f of 3 means instead of writing negative x squared, it'll be negative 3 squared plus 7. One thing people always forget in these types of equations is Pemdas. So when we're dealing with negative parentheses 3 parentheses squared, we're doing exponents first, because when we spell out Pemdas, it's parentheses, exponents, multiply, divide, blah, blah, blah. So exponents first, we would square the 3, which is 9, and then multiply by the negative that's in front. So this will end up being negative 9 plus 7, which gives us negative 2. Okay, f of negative 2, same thing, pay attention to your negatives and your parentheses. So plugging in negative 2 squared will be 4, and then multiply by the negative in front. So that gives us negative 4 plus 7. And then that gives us 3. If we're doing this with variables, same thing, we're still just plugging stuff in for x. So it'll be negative, and then instead of writing x, I would write 3a, that gets squared, plus 7. So 3a squared would be what I would do first for the exponents. So that would be 9a squared, and then multiply by the negative in front. There's nothing that we can combine there, so that's it. And then finally, f of b minus 1. Same thing, let me plug stuff in. And then I'd have to square b minus 1 first, but if I'm squaring something where I have like a binomial in it, so it's got a minus sign, 2 terms, then I need to FOIL it out. So it'll be negative, and then I gotta FOIL out the b minus 1 times b minus 1 plus 7. So FOILing out b minus 1 twice gives me b squared minus 2b plus 1, and then multiply that by the negative in front. to get negative b squared plus 2b minus 1 plus 7, and finally we can combine like terms to get negative b squared plus 2b plus 6. Okay, so that's evaluating functions. Then one more thing that you should have seen back in pre-calculus. The last thing I want to do is the difference quotient. So hopefully you remember seeing this in pre-calculus. The difference quotient, oh, I know how to spell. The difference quotient is the thing where we do f of x plus h minus f of x all divided by h. And you'll see why we're doing the difference quotient in this first chapter that we do in calculus, but for now I just need you guys to be able to plug things in correctly into it. So let's say we're using the same f of x as before, so the negative x squared plus 7. So if we're doing the difference quotient, or plugging into the difference quotient, then f of x plus h will actually be us plugging in x plus h where we see x. So it'll be, instead of negative x squared, it'll be negative x plus h squared plus 7. So that all right there is us plugging in the f of x plus h. And then we're going to subtract f of x. Well, f of x was just negative x squared plus 7. And I'm going to leave that in parentheses because I want to make sure all my signs stay good. So that's these two parts from our original difference quotient formula. Then we're doing all that and dividing by h. So at this point we really just need to simplify everything. So I'm going to FOIL out the x plus h, and then from there stuff should cancel out on top, which is kind of nice. So because I'm squaring it, I'd have to FOIL that out. And then minus a negative x squared will give us a plus x squared, and then distribute that negative to the 7 to give us a minus 7. Oops. All over h. And then FOILing that, we get x squared plus 2xh plus h squared. And the rest of it. And then just making sure I distribute my negative sign. At this point, I just want to simplify everything I can. So I see that I have a plus 7 minus 7. Those will cancel out. I have a negative x squared and a plus x squared, so that'll cancel out. So on top, that leaves me with negative 2xh minus h squared all over h. But on top, I can simplify more because I can factor out an h. So that'll give me h times negative 2x minus h. And since I have an h on both top and bottom, those will cancel out, leaving me with my final answer of negative 2x minus h. And that is the goal. Every time you do the difference quotient, you're looking for things to cancel out. And they should. If they don't, that means you might have messed up some like plus or minus signs in there, so you want to double check. And I know these problems are a little bit longer just because there's a lot of simplifying to do, so you just want to be really careful in your simplification. Make sure you get your plus and minus signs, distribute your negatives, multiply correctly, add and subtract correctly, all that good stuff. That's it for this review section. So